Hi, everyone. Thank you so much for coming. I'm Lorena, and today I'm going to talk to you about micropackaging reusable data science pipelines in Python. But first, who is the stranger and why am I talking to you? Hi, I'm Lorena Balan. I'm a senior software engineer at Quantum Black. Quantum Black is, for those who don't know, is an advanced analytics consultancy that was acquired by McKinsey 6 or so years ago. I'm originally from Romania, hence the funky letter in my name. I got my degree in computer science from University of Bristol, and I have over 4 years of experience as backend engineer. I joined Quantum Black in March 2019 and have since worked on a product called Kedro, which I'm going to speak about more in just a second. The agenda for today looks something like this. First, I'll explain a bit more about the context in which the problem of micropackaging arose. I'll quickly show how the Kedro solution works in a live demo, fingers crossed, and then I'll explain what's powering it under the hood. At the end, I'll spend a couple of minutes on reflections and what's next in the future of this functionality. So first, a few quick words on Kedro. It's an open source Python framework that enables data scientists, data engineers, and machine learning engineers collaborate more seamlessly and develop more robust, maintainable, reproducible code for their data pipelines. Traditionally, data scientists don't have a software engineering background, so this tool aims to instill some of those good software engineering best practices into a data science workflow. And there are four main components of Kedro. Project template, this is just a folder structure of a project, so it sets a consistent standard. It makes it easy to bring people in halfway through a project and they are able to find their way around. Then you factor out configuration separate from code, so you don't have hard-coded file paths or parameters or sensitive information like credentials all over the code base. The catalog is probably the most popular feature in Kedro. It's a collection of data connectors that handle reading and writing of data. It basically ensures you don't have to write a single line of pandas read CSV or pandas to CSV in your life, because this takes care of that boilerplate code for you, so you can focus on more important problems. And finally, we have nodes and pipelines abstractions. Nodes are just thin wrappers around Python pure functions, and pipelines are just sets of nodes arranged in a DAG or a direct cyclic graph. And of course, it all ships with the command line interface, so you can do Kedro new, Kedro run, etc. And the UI, which is actually a separate plugin to visualize the pipeline. I encourage you to go and pip install Kedro and Kedro Viz and just have a play with them and see how they fit your workflow. So in terms of micropackaging, what is the problem we are actually solving? Well, teams wanted to reuse code they wrote on every client engagement. Most of the time, this means entire data pipelines. Remember our pipeline object in Kedro, but sometimes it also refers to just utilities like helper functions, reusable components, etc. So they wanted a very simple way to reuse code across projects, but actually not only reuse it, but also adapt it from use case to use case. That's it. That's the one-liner. And with that came a set of user requirements. First, they wanted tests to be bundled together. And the reason for this was that it demonstrated confidence to clients with regards to code quality and code coverage, test coverage, but also remember they wanted to adapt code. And when you do that, you may also need to update the tests, or at least make sure that they still pass and you haven't broken key functionality. Then there was the ability to rename packages. This was important because people wanted to avoid references to internal assets. At Quantum Black, we have teams that work on assetizing analytics pipelines or relevant analytics utilities, and they wanted to be able to integrate those in a client project without worrying about breaching IP clauses or anything like that. Next was that some people wanted to be able to get the code as source, not just as a library. The most common use case is the ability to remap some data sets or parameters in the existing pipelines. But also if they wanted to change a node or add different nodes to the pipeline, remember node is a Python function. This would help them navigate that customization better. And it also gave clients a sense of ownership if that code lived in the code base and not in some side packages somewhere. It gave them visibility and transparency. Easy packaging. Remember that a good portion of our users are beginners or data scientists minimal computer science background, so we didn't want to make them feel overwhelmed, like they had to learn a bunch of extra stuff about Python packaging in order to be able to use this feature. And finally, we have bulk operations. This is useful as it ensures reduced labor, no need to run multiple CLI commands or write a script to run those multiple CLI commands, while providing a declarative interface in which you can clearly see what is about to be packaged or what is about to be unpacked into your Kedro project and how. So that's it. These are the 5 main requirements. Now I'm going to switch gears a bit and show you a live demo of how the Kedro solution works. It uses bleeding edge functionality, so not all of this has been released yet, but it gives you a sense of where we're going, and it makes use of 2 main components. One is Kedro CLI, and we also make use of the PyProject toml file as a manifest file. So let me close this presentation and change screens. So hopefully you see my terminal and my Sublime. And in here I have, I've taken the liberty to create already a Kedro project, and this is what it looks like. It's just an extension of our spaceflights tutorial that we have in our documentation. And it's called spaceflights. So you can see we have some configuration here, we have some data here, and we have the source code where we have some tests and some pipelines. And I've added a pipeline called flights reporting with some nodes and a pipeline. You can see here what it looks like. This is how you would construct a pipeline in Kedro. We have a very simple Python function. It's just an identity function right here, and we wrap it as a node. So we pass the function and some inputs and some outputs. It just passes around the same value. And I import the function here. Remember this import because this will be the one that we'll be looking at a lot. And just to show that this is a real thing, I can run this like that. Yeah. There are no errors. Yeah, so it's a very simple pipeline. Now, let's look at packaging. So let me clear this. I want to package the folder that resides in pipelines, flights reporting, and I want to rename it. I want to name it just reporting. Cool. So just to show you that this was created in here, I have a tar file right there. Let's look at the contents of that file. So if I do this, you can see that my nodes.py, pipeline.py files are there. I have some configuration parameters, and I've also packaged the tests. The next thing I can do is actually show you the contents of the files. So let me run this now and show you. Let's look at the pipeline.py file. So you can see now the import has changed from spaceflights.pipelines.flights reporting to just reporting, because that's the name of the actual package. And similarly, in tests, you will see that also this import has changed from the longer version to just the name of the package. Cool. Let me clean up after myself. And let's actually unpack these properly. So let's pull them instead. And it resides in here. And I want to extract them somewhere else. Let's say I want to create them in some libutils folder. And let me show you. So you can see now, so all the Python module path that I've passed around, the dot separated strings, they're all relative to the Python package, which in my case is called spaceflights. So I want to create a libutils, and it's here. And then I also should have them in tests. Yeah. And I can actually show you the content of them. So let's look at space flights pipeline. And the import has also changed correctly. And once the package is created, once we have that tar file, a user can do anything they want with it. They can publish it to Pipey. They can upload it to some repository somewhere. Like the world is your oyster. We just create the package for you. Let me switch gears a bit and let me clear up some folders. So this and also the tests. Cool. So I mentioned a PyProject YAML file as a manifest file. What that means is you see we have these two sections. And this is telling us what we want to package and what options we want to pass. Line 7 is basically doing exactly the same that I've shown you from the CLI. And then I've also want to package some tools, package as MLOps utilities, because that's a that's a buzzword these days. And I want to save it actually somewhere else. I don't want to save it in dist. And then on pull, similarly, the path to the tar file and some options. So let me actually create that tools directory because I don't think it exists yet. And let me also create some files while I'm there. And we have some very useful stuff as well. Cool. And now the bulk operation is just by doing package --all. And what that will do is it will read the PyProject YAML file and will just run a series of packaging operations, which you can see here. And let's look at the tree. So you can see we have this reporting in a dist folder again. But also my custom location, source spaceflights lib, and I have this package right there. And if I do the mirror of it, which is pool --all, and show you the tree structure, you can see I have the reporting package extracted here, where it extracts it by default in the spaceflights package, and then I have this flights MLOps utilities, which I wanted to save in here. Remember, I didn't write any tests for this, so I don't find the equivalent tests here, but I do have them for reporting, which is to be expected. Yeah, and I think that's all I had in the live demo section. So I can move back to my presentation. Cool. So let's remind ourselves of the user requirements. First one was that tests needed to be bundled together. Tests were packaged and unpacked via the relevant commands, the pool and the package. So this is done. We saw the --alias flag that can rename a package, and that change trickles down through all the files and imports are refactored. So this is also done. And then Kedro pipeline pool extracts the package contents into the code base in the right place with the imports correctly refactored, so we have it as source as well. Number 4, I'd say this is achieved as well, as we have just a couple of simple CLI commands. You don't need additional prep to make it work. And finally, of course, we saw the PyProject YAML file and the --all CLI flag to enable bulk operations. So this is ticked as well. So what's under the hood? The import refactoring magic is done using a glorious library called Rope. The reason why this is cool is because it's one of the main libraries modern IDEs use to refactor code. So if you use PyCharm or VS Code, chances are you would have already used this library underneath. And if it's good enough for them, then it's good enough for Kedro. You will have seen we generate tar files for our packages, and that's a switch from what we were doing before. Previously, we were generating wheel files. The reason for this is that after digging a bit deeper, we found this distinction between build distribution, a wheel, and a source distribution, which was actually closer to what we needed conceptually as well. Our wheels were a bit unorthodox in that we were shoving 2 packages in the same wheel, one for source and one for test. And it's not what you would see in your typical Python package. So that's why we switched, as source distribution has some understanding of tests being a thing. And a user can also generate a wheel from a tar file. So for people that wanted to use it as a library and reference it in their requirements.txt, they could still do that. The functionality uses setup tools under the hood. So we built a setup.py file on the fly for the code that we're about to package. We ended up with setup tools because that's what we're already using for other commands, and also for on our side as developers of Kedro, so we use the same thing. Other libraries we use are Click for CLI and FSPec. If you haven't heard of FSPec, it's a really cool package. It provides a unified Pythonic interface to local, remote, and embedded file systems. We use this for our data catalog, but in micropackaging, we use it to read the tar file at pull time. I've only demoed with local file storage, but that tar file might as well be in a bucket in S3, and it would still work. You just have to add a prefix to the file path in the CLI command, but otherwise it's fine. And of course, TOML parsers to be able to read and write to the PyProject TOML file. Couple of quick reflections. Python packaging is wilderness. When I looked at different libraries and how they package, I found so many ways this is done. Setup.py, setup CFG, requirements.txt or no requirements.txt, manifest.in, talks, poetry, you name it. The second one is working with Rob made me realize we do really take for granted all the thing modern IDEs do for us sometimes. And all in all, this was a pretty interesting but challenging list of requirements because of the variety of stakeholders we had and their own set of preferences and priorities, such as consuming as source versus as a library, renaming the package, etc. It was something that felt brand new, that we haven't seen a strong model of anywhere else. And in terms of the future, I can split this into more immediate future versus distant future. First is the smart bulk packaging, and I have an example on the next slide to illustrate actually what I mean. So in this example, utils in here should be renamed to sigma, and any references inside of it to alpha should actually refer to beta. And then alpha should be renamed to beta, and any references inside it to utils should refer to sigma. At the moment, this doesn't happen. It would just read the file line by line and do its best. However, we want to make it smarter than that. Then the next one is handling dependencies between micropackages. It is within reason to find that a pipeline depends on another pipeline or a micropackage on another micropackage. But what should happen when that's the case? Should they all be bundled together? Should there be another line in the requirements of the package? That's something we need to think about a bit more. For a distant future, we see potentially having a distinction between PyProject TOML and requirements.txt, where PyProject TOML will be where you specify your source distributions, what you'd like to unpack, and requirements.txt for libraries, what you'd like to install. And finally, imagine if we want to publish all our resulting packages to a bucket in S3 or some PyP compliant Artifactory. You just have to configure that endpoint somewhere, and it's done for you at publish or push time. And the same goes for unpacking from a certain endpoint or pool. And that is it from me. I would like to thank you all for your attention, and I'm happy to take questions now.
Thank you very much, Lorena. We do have a question. So the question is, why not write a build backend instead of relying on setup tools? You are already using setup tools, so you are already halfway there.
Yeah, well, we have, we wanted to rely on stuff that's already out there in the community rather than build our own, because as much as we can, we'd like to leverage like Kedro agnostic tools in a way. So we didn't want to build our own. But we do also have, so internally you also have a repository where these micropackages are discovered and they can be pushed or published, and that's a different team that takes care of that, but we interface with them frequently to make sure this happens okay.
Cool. So I have another question. What features differentiate Kedro from other tools that try to package ML pipelines such as MLflow?
So MLflow has to do more with experiment tracking, model registry, stuff like that. Whereas with Kedro, we focus on the development side of the pipeline. So how you pull in your data, how you like wrangle or pre-process your data, and coming up soon, we'll have some experiment tracking built natively in Kedro. But the way we see it is that MLflow is an integration, it's not a direct competitor, because we look at different parts of the, I guess, the ML lifecycle.
Cool, thank you. Another question. How do you distribute micropackages?
So like I said, at the moment, we encourage our internal users, if they have something they're very proud of, to push it to this internal store that we have that's built on top of GitHub. And there's easier discoverability features there that they can look for these packages. But it's not just fixed on just that one implementation. We want it to work for open source users everywhere. So it's up to the user where they want to put those packages. They can put it on PyP, and Kedro Pipeline Pool will still work with something that's uploaded on PyP, because it doesn't pip download first. Or they can, as I said, they can put it on a S3 somewhere, or any file system that interfaces with FSPec, and they just pull the tar file from there.
Cool, thank you. I think that's what we have for questions for now. So unless someone posts something really quickly, we'll be finishing the QA session and going for the next talk. So thank you very much, Lorena.
Thank you.
See you around.